In this video, we're going to use some tools from statistics to look at some historic data by assets and try to figure out what we think might happen in the future, or what maybe should happen in the future. So if you'd like to learn more about predicting future stock prices using historic data, stick around and we're going to get into it. One of the great things that we can do once we know the level of idiosyncratic risk facing a company is that we can actually use that to roughly predict what the stock is likely to do in the future. Because we know that normally distributed data follows a predictable distributional pattern, we know that 68% of observations should be within one standard deviation of the mean. So, if you know the mean and the standard deviation of returns for a particular stock, we can say with 68% confidence that the expected return for that stock is the mean plus or minus one standard deviation, or sigma, from the mean. Historically, the S&P 500 has returned about 12% per year with a standard deviation of 20%. That means we can add 20%, the standard deviation, to the mean of 12% and say that the upper bound of the 68% of observations within one sigma of the mean is at 32%. We can also subtract 20% from the mean of 12% and conclude that the lower bound is at an 8% loss, which is 12% minus 20%. Since 95% of observations lie within two standard deviations, we can simply add and subtract 2 sigma to the mean to get the 95% confidence interval for returns for the stock that we're analyzing. If our investment is the S&P 500, 12%, which is the mean, plus 2 times 20%, which is the sigma, makes the upper bound of our 95% confidence interval 52%. Following the same logic to determine the lower bound gives us 12% less 2 times 20%, or a minus 28% return, or a loss of 28%. If 95% of the observations are between a 28% loss and a 52% gain, we know that the remaining 5% of the observations are outside of that window. So what if I asked you the probability that the S&P would return more than 52% next year? Since the probability of landing outside of the 95% confidence interval is only 5%, that includes returns below a 28% loss and above a 52% gain, and we assume symmetry in the distribution, we can simply divide the 5% in half and conclude that about 2.5% of the observations will be above a 52% gain. We can do the same thing to answer similar other questions about the probabilities of various returns. Keep in mind one thing though. Stock returns are not quite normally distributed, and the method we are using here assumes they are. Since stock returns have an abnormal kurtosis, or density, around the mean, we are taking some chances in using these methods in violation of their mathematical assumptions. However, it is the best tool we have available, so as long as we're conservative with our estimates, we are likely to be reasonably close in reality.